Find the equations of line which contains the point. Find the equations of lines which contains the point 13, point A 13, and whose sum of intercepts on the coordinate axis is 0, and the sum of his intercepts on the coordinate axis is 0. Two conditions are given in this example. If you observe carefully, then two conditions are given, that find the equation of lines. Here word lines means obviously there are two lines which pass through or which contain the point 13 and whose intercept, sum of intercepts is 0. This one is given and this one is given. Two conditions are given. This line contains the point A13. How this situation of these lines, let us see here. This is x-axis and this is y-axis. Point line passes through point, contains the point 13 means it passes through point 13. X1 is here, 3 is here, 1. So line passes through point A13. And how is the nature of that line? Which passes through point 13 and the coordinate, sum of the coordinates is 0. So before that, we will write something here. Here the sum of the intercepts on the coordinate axis is given. So we will start with two intercept form or double intercept form of line. Since the equation of line in double intercept form is x upon a plus y upon b is equal to 1. The first condition is given that the line contains the point A13 as this line 1 contains point 13. Therefore, x equal to 1 and y equal to 3 satisfies equation 1. That is 1 upon a plus 3 upon b is equal to 1. We get this equation in two intercepts a and b. Now we have given one condition or relation of these intercepts, that is the sum of the intercepts on coordinate axis is 0. But a plus b is equal to 0. That is given. Remember that a plus b is equal to 0 is given. So can we conclude here results about a and b, that the sum of two numbers is 0. Then the sum of two numbers is 0 if both the numbers are 0 and both are negatives of each other. Therefore here we have two conditions. First, this is possible this is possible only if A equal to B equal to 0, and second condition that A is equal to minus. So when A and B both are 0, we can't put both here because these are at the denominator side. So when both intercepts are 0, means line passes through origin. So line will be like this, which passes through origin. This is first line passing through point A13, and the sum of the intercepts is 0, means both intercepts are 0, 0, then their sum will be 0. So this is first line, I will call it as L1. Now the sum of the intercepts is 0. So when intercepts are negatives of each other, A equal to minus B, then their sum will be 0. So A equal to minus B means suppose X is positive, Y will be negative. If X is positive and Y is negative, so line may pass through this point on positive x-axis and negative x-axis. But point is in first quadrant, so line which cuts positive x-axis and negative x-axis, then it never makes equal intercepts because both are negatives of each other. So intercepts are equal. So it is not possible for positive x and negative y. It is not possible for positive x and negative y axis. But it may be possible for negative x axis and positive y axis, because that line may be like this. Which makes equal intercepts here. So A equal to minus B. In this case, they have these two lines L1 and L2, one passing through origin and other making equal intercepts of this A, and this is also A, but A is equal to negative of B, means minus. Here A equal to, we will write here minus B, not plus A, because it is positive x-axis, but A equal to minus B, and here B plus B. If y intercept is B, x intercept is minus B. Here A equal to 0, B equal to 0. So both intercepts are 0, means line passes through origin and this point. So equation of line becomes, therefore the equation of line passing through origin and point 1, 3 is, here points are 1, 3, so it is equal to 1 into y equal to 3 into x. Equation of line passing through point 1, 3 and origin is 1 into y, here 1 is x coordinate into y, 3 is x coordinate, y coordinate into x. Therefore the equation will be y equal to 3x, or that is 3x minus y equal to 0. Actually we have found the same in our previous example. Now in case of second situation, A equal to minus B. So line passes through 1, 3, so we get this equation. Put A equal to minus B in this equation, or B equal to minus A, whatever you can put. So equation, therefore the equation of line 1 becomes, equation of line 1 becomes x is x upon A equal to minus B plus y upon plus B is equal to 1. Or we can solve these two equations, then we get values of A and B. instead of putting that value, we will solve these two equations. Therefore, the equation of equation 2 becomes 1 upon a plus 3 upon b. B is equal to minus a, that is equal to 1. So from this we get 1 minus 3 is equal to a. Therefore, a is equal to minus 2. Now put a equal to minus 2. A equal to minus 2 implies b is equal to plus 2. If a is equal to minus 2, we get b is equal to plus 2. Use those values here. We get once again. Therefore, equation 1 implies x upon minus 2 plus y upon b, that is 2, and it is equal to 1. So it implies multiplying both each term by 2, we get, or multiply each term by minus 2, then we get x minus y equal to minus 2, which implies x minus y plus 2 equal to 0. Okay, once again see the second case. In a equal to minus b, we will put that a equal to minus b in this equation 2, so that we get 1 upon a plus b upon minus a, that is equal to 1. From that we get value of a, that is equal to minus 2. If a is equal to minus 2, obviously b is equal to plus 2. So put these two values in equation 1, x upon minus 2 plus b upon 2 equal to 1. So that we get equation x minus y plus 2 equal to 0, and 1 as 3x plus y equal to 0. So these are the equations, two equations. One is 3x minus y, that is passing through origin is 3x minus y equal to 0, and the line which not passes through origin, its equation is x minus y plus 2 equal to 0. Okay. So these are the equations of two lines. Let us move towards the next one. Example number 8. Find the equations of altitudes of the triangle. Find the equations of altitudes of a triangle whose vertices are given a2 5, b6 minus 1, and vertex c is minus 4 minus 3. In this example, a, b, c are the vertices of a triangle, and we have to find the equations of altitudes of triangle. Let us see first figure here. Consider triangle A, B, C, in which AP is altitude on side BC. Then BQ is altitude on side AC, and this CR is third altitude. As we know that three altitudes of triangle are concurrent, means they passes through point, suppose here H. All these altitudes passes through point H. Now we want the equation of altitudes, means we want all the equations of altitudes, three altitudes. So let us find first altitude AP. Here the point A is 2, 5, consider it as x1, y1. Point B is 6, minus 1, consider it as x2, y2. Third vertex C is given minus 4, minus 3, consider it as x3, y3. Now the P is the foot of the perpendicular or altitude, but we can't find the coordinates of P because the here ratio is not given or it is unknown. But we can find the slope of line BC, and from that we can find slope AP because side BC and altitude AP are perpendicular to each other. So we can find slope of altitude AP and this altitude passes through point. So using slope point form we can write the equation of altitude AP. So let us first find the equation of altitude AP. Similarly we can find the altitudes of equations of altitudes BQ and CR. In first part, given A, B, C that we have written there, here the slope of side BC is equal to B and C are x2, y2, x3, y3. So difference in y coordinates, that is y2 minus y3 upon x2 minus x3. It is equal to y2 minus y3, y2 is minus 1, my y3 is minus 3, minus minus plus 3 upon x2 is 6 and x3 is minus 4, its negative is plus 4. So it is equal to 2 by 10, that is 1 by 5. So that is the slope of side BC. As altitude AP is perpendicular to side BC, therefore slope of AP into slope of BC is equal to minus 1. Is it okay? Because if two sides or lines are perpendicular, the product of their slopes is minus 1. So slope of AP into slope of BC is given, or we have found, that is 1 by 5 is equal to minus 1, which implies slope of AP is equal to 5 into this, that is equal to minus 5. So this is the slope of AP, and AP passes through point A, and altitude AP passes through A to 5. Therefore its equation in slope point form using slope point form, we get its equation in slope point form is y minus y1 equal to, here point is 2, 5, that is x1, y1, that's why we get y minus y1 equal to slope of AP, that is minus 5 into x minus x1. Therefore it is y minus y1 is 5 equal to minus 5. Now let us here write for first y minus y1 equal to m into x minus x1, minus 5 into x minus x1 is 2. Now simplify this, We get here minus 5 is taking to the left, it becomes 5 plus 5x. Here is plus 1. This will become plus 10. Taking to the left becomes minus 10. So minus 15 equal to 0. This is the way to find the equation of altitude AP. Now, in short, we will find the equations of remaining two altitudes. Here, the slope of, we will proceed this process. Similarly, the slope of AC will be difference in y coordinates, that is 5 minus 3, that is plus 8 upon this 6. So it is equal to 4 by 3. So slope of AC will be 4 by 3. From that we can find slope of BQ, which is perpendicular to this. Its slope will be minus 3 by 4. Negative reciprocal of this slope. So minus 3 by 4 is slope and passes through this point. So equation of altitude BQ is y minus plus 1, point is this, equal to slope is minus 3 by 4 into x minus x1, that is 6. Simplify this, multiply each term by 4, so you get 4y plus 4 equal to, multiply this by minus 3, so minus 3x plus 18. After simplification we get 3x plus 4y. Taking this towards left, we get minus 14 equal to 0. So this is the equation of second altitude BQ. Let us move towards third. As we want to find the equation of altitude CR, CR is perpendicular to AB. So first find the slope of segment AB or side AB or line AB. It is the difference in y coordinates, that is 5 minus plus 1, that is 6 upon 2 minus 6, that is minus 4. So it is equal to minus 3 by 2. So slope of AB is minus 3 by 2. So slope of CR, its negative reciprocal, that is 2 by 3. So slope of CR is 2 by 3. So equation of altitude CR is y minus point is x3 by 3. So y minus y3 is equal to slope m into x minus x3. Put the values. Y minus y3 is minus 3. So minus plus is equal to slope m is 2 by 3 into x minus x3. x3 is minus 4. So it becomes minus plus 1. Just simplify that. It will be 2x. Answer will be 2x. 3y. So it becomes minus 3y. This becomes 8. 8 minus 9, that is minus 1 equal to 0. So this will be the equation of third altitude. Okay. Let us once again check it. 3y plus 9, 2x minus 3y plus 9 is correct. So it is 2x minus 3y minus 1 equal to 1. So these are the equations of three altitudes. We just first make clear how to find the equation of one altitude. Similarly, you can follow for remaining two altitudes. First find the slope of one side. From that slope find the slope of altitude. And now using slope point form we get equation of altitude. Okay. Let us move towards the example number 9. In this example, we will find the equations of perpendicular bisectors of triangle. Find the equations of perpendicular side bisectors of a triangle whose vertices are P minus 1 8, second vertex Q 4 minus 2, and third vertex R is minus 5 minus 3. Okay, it is 1 second draw the figure. Here triangle ABC is taken surface. The triangle ABC, sorry, PQR. PQR is a triangle whose coordinates are P, that is minus 1 8. Let us consider it as x1 y1. Coordinates of Q are 4 minus 2. Consider them as x2 y2. And coordinates of R are minus 5 minus 3, so they may be x3 y3. Then we have to find the equations of perpendicular side bisectors. Perpendicular side bisector is nothing but the line which passes through midpoints of sides, and it is perpendicular to that side. So that perpendicular bisector will be like this: a line which passes through midpoint of this side. Let midpoint be A, and we call this perpendicular bisector line as X. This line X passes through point A and it is perpendicular to this side. Okay, so what can we do here? We can find easily the coordinates of point A, which is midpoint of Q and R. So using midpoint formula we get coordinates of A, and if we find slope of QR, then from that slope we can find slope of line X, because X is perpendicular to side QR. So using slope and point, again we can find the equation of that perpendicular side bisector. Let us first find the equation of that line X. After that we will move towards second one. Here the slope of side BC is in the same way. We can write slope of BC. Instead of BC, here is our side is QR. So slope of side QR is equal to y2 minus y3. y2 is minus 2. y3 is minus 3. So minus minus plus 3 upon x2 is 4. x3 is minus 5, so it becomes minus minus plus 5, and is equal to, so minus 2 plus 3, that is minus plus 1, plus 1 upon, this is 9. So slope of QR is 1 by 9. Here this perpendicular bisector X is perpendicular to side QR. So slope of line X into slope of QR is equal to minus 1. So slope of X into that slope is 1 by 9 into minus 1. So slope of line X is equal to minus 9. Okay. Now this perpendicular bisector x passes through point A. Let's find A here. A is midpoint of QR. So A is x2 plus x3, that is 4 plus minus 5 upon 2, and y2 plus y3 is minus 2 minus 3 upon 2. That is, it is 4 plus minus 5 and minus 2 plus minus 3 upon. It is minus 1/2 and this one is minus 5. So this is midpoint A. Therefore, this equation is slope one form, means equation of perpendicular side bisector. Therefore, equation of perpendicular side bisector x in slope point form, we get this as y minus y1. Y1 is our minus 5/2, that is plus 5/2, into slope is minus 9 into x minus minus half, that is plus 1. Let's simplify this. First multiply each by 2, we get 2y plus 5 is equal to minus 18 into x plus 1. Multiplying each one by 2, we get minus 18 plus this half remains as it is, because we are multiplying to this line. So this become minus 18x plus minus minus 9. Okay, take that 18 to the left, minus 18 to the left, we get 18x plus 2y. Taking as minus 9 to the left again, we get here plus 14 equal to 0. So this is the way to find the equation of perpendicular bisector x, or perpendicular bisector of side QR. That is this. We can cancel 2 from each term, that is 9x plus 1 plus 7 equal to 0. This will be same. In second case, what to do? We have to find the midpoint of this side. That is, suppose B is the midpoint of side QR, and after that we have to consider a line which passes through B and perpendicular to this. Instead of x, it will become convenient to take element because x and y are coordinates. So we will take here instead of x, consider L. Let us consider the second perpendicular side bisector as M. M is the perpendicular bisector of side PR. Here B is midpoint. It can be obtained by using midpoint formula. That is minus 5 plus minus 1 is minus 6 upon 2, that is minus 3, and minus 3 plus 8 is 5 upon 2. So this is midpoint of side PR. The slope of this PR, in the same way, the slope will be minus 3 minus 8, that is minus 11 upon minus 5 minus minus plus 1, that is minus 4. So it is nothing but 11 by 4. So slope of this will be 11 by 4. 8, 3, 11 by 4. From this, the slope of this perpendicular is minus 4 by 11. If it is 11 by 4, slope of perpendicular will be negative reciprocal of that. So negative and reciprocal. That is minus 4 by 11. So knowing this slope and point, you can use slope point form and the equation of line n. It will be y minus 5 by 2 equal to minus 4 by 11 into x plus 3. Is it okay? Point is y1 is minus 5 by 2 and x1 is minus 3. So we get this. Therefore, on simplification, we get this as 2y minus 5 upon 2 is equal to minus 4 by 11 into x plus 3. So multiplying by 11 and 2, we get 22y minus 55 is equal to multiply this by minus 8x and this minus 8 plus 3, that is minus 24. Once again simplify, take that 8x to the left becomes positive, so 8x plus 22y, this becomes plus 24, so becomes minus 31 equal to 0. So this will be the equation of line. There will be no any change, but you can't take any common number from all terms at a time. Similarly, you can find the remaining slope of equation of third perpendicular side bisector. I will let it for you. You can solve it because we will cover third example, last example of different type. Let us see example number 10. Find the equations of coordinates of orthocenter find the coordinates of orthocenter of a triangle whose vertices are a 2 minus 2, b 1 1 and c minus 1 0. Let us see how to solve this type of question. In this question, 3 vertices of triangle are given. So let us draw first figure of triangle. This is point A, that is 2 minus 2. Consider it as x1 minus. Vertex B is 1 1. Consider it as x2 y2. Consider third vertex C as -1 0, so it is x3 y. In this example, you have to find the coordinates of orthocenter. First tell me, what is meant by orthocenter? Orthocenter is nothing but the point of intersection of altitudes. Okay. So in our example number 8 also, we have found the equations of altitudes. Similarly, here we will draw the altitudes. Let this AP is altitude on side BC. Then BQ is another altitude corresponding to side AC. We know that third altitude passes through this point, and we want to find here the coordinates of orthocenter. So coordinates of orthocenter means point of intersection of these two lines or three of the altitudes. But we can find the point of intersection by using at least two lines. So no need to draw third altitude here. From only finding these two altitudes, we can find the coordinates of altitude, that is orthocenter. Let us call it as H. So only find the equations of altitude AP and altitude BQ and solve those two equations to get the coordinates of orthocenter. Let us start here. Again, here ABC is a triangle. Let AP is perpendicular to side BC and BQ is perpendicular to side AC. So these are AP and BQ are our two altitudes. AP is perpendicular to side BC, so find slope of BC. Since slope of side BC is equal to, we have considered B as x2 y2, C as x3 y3. So slope of side BC is equal to y2 minus y3 upon x2 minus x3. y2 is 1, y3 is 0, x2 is 1 and x3 is minus 1, so it becomes plus 1. So 1 upon 2, that is half. That is half is the slope of BC. But AP is perpendicular to BC, which implies slope of AP into slope of BC is equal to minus 1. So slope of AP into slope of BC is half equal to minus 1. Therefore slope of AP is equal to minus 1. We can consider it as M1. So here M1 equal to minus 1. Therefore the equation of altitude AP in slope point form is y minus AB passes through point A x1 and its slope is minus 2. So its equation is y minus y1 equal to m into x minus x1. So equation is y minus y1 is minus 2. So it becomes plus 2 here. Slope is minus 2 and x1 is plus 2. So x minus 2. Simplifying this, we get y plus 2 equal to this as minus 2x plus 4. Taking all terms to the left becomes 2x plus y. Taking here we get minus 2 equal to 0. So that this is the equation of altitude AP. This is the equation of altitude AP now. Let us find the equation of altitude BQ. This is the way to write. In short, I will find here the slope of this AC from difference of y coordinates, that is minus 2 and 0 is minus 2 and 2 minus minus plus 1 is 3. So slope becomes minus 2 by 3. So slope of BQ becomes 3 by 2. Because this is 2 by 3, we write 3 by 2, negative becomes positive. So it is 3 by 2 is the slope of BQ. It passes through this point. So equation of BQ is y minus y2 into this will be our slope m2. So m2 into x minus x2. So this is therefore y minus y2 is 1 equal to slope m2 is 3 by 2. x1 is 1, x2 is 1. So we get equation as y minus y equal to 3 by 2 into x minus 1. Multiply this by 2, we get 2y minus 2 equal to 3x minus 2. After simplification, we get in this form 3x minus 2y minus 1 equal to 0. So that is the equation of altitude BQ. Now we need the coordinates of orthocenter. So we will write here these are the equations of altitudes first and second, and we need their point of intersection. Now by solving, let us call this equation as equation 1, this as equation 2. So by solving equation 1 and 2, we get x plus y equal to 2, and second equation is 3x minus 2y equal to 1. Multiply this equation by 2, we get 4x plus 2y equal to 4, and this will be as it is 3x minus 2y equal to 1. So adding these two equations, we get 7x equal to 5, which implies x equal to 5 by 7. So this is the x coordinate of point H. Put x equal to 5 by 7 in any one of these equations. I will put here. Therefore 3x minus 2y equal to 1, which implies 3 into 5 by 7 minus 2y equal to 1. It is 15 by 7 minus 2y equal to 1. So 2y equal to 15 by 7 minus 1, that is 8 by 7, which implies y equal to 4 by 7. Check the calculation. I have used this equation. In this equation, we have put x equal to 5 by 7, so it becomes 15 by 7. Taking 2y to the right becomes positive. Taking this 1 to the left becomes 15 by 7 minus 1, that is 8 by 7. So 2y equal to this, y equal to 4 by 7. So the orthocenter or the coordinates of orthocenter are 5 by 7 and 4 by 7. So this is the way to find the coordinates of orthocenter. No need to find the equations of 3 altitudes. Just find equations of any 2 altitudes and solve those 2 equations simultaneously. You will get the equation of coordinates of orthocenter. Here we get 5 by 7 and 4 by 7. So I think in this lecture we have covered all different types of examples. If you learn all these examples carefully, everything will be clear. Thank you.